Welcome to MSPTDA video number 9. Hey, in this video, we're still talking about Power Query, but in this video, we get to talk about M code. This is the computer language behind every solution we build in Power Query. Now, we're definitely going to talk about the ever important list of values. Those are the things Power Query can generate. We're going to talk about expressions, which are our formulas. We're going to talk about custom functions, parameters, and much more. Let Power Query equal power. Well, then M code equals more power. Now, really, here's all of the topics we're going to cover. These are many of the nuts and bolts of how to write your own M code or understand the M code that the user interface generates. Now, I'm going to go over to the sheet resources. Here's 4 great resources. And the number 1 resource is the Microsoft Power Query for Excel. And it says for Excel, but this is the official formula language specifications. It is the manual that Microsoft puts out that tells you how Power Query M code works. Now, number 2 and 4, we'll see how to generate help right inside of Power Query. And of course, searching Google, the Microsoft site tends to be pretty good. Just to remind ourselves of what Power Query does, hey, this is video number 9, and we've seen how to extract and import from multiple sources, clean and transform the data, load to all sorts of different places, use Power Query to create data sources, data models, finished reports, parameters for other queries. Ooh, actually, we'll get to see that in this video for the first time. And of course, it can help to replace complex Excel array formulas. But anytime we do these tasks, behind the scene is M code. That's Power Query's formula language, Power Query's function-based case-sensitive language, also known as the M language. The M, well, what does that M mean? Data mashup language. Now, of course, creating Power Query solutions could be done with a user interface or by writing M code. We've done lots of the user interface and a little bit of M code. But in this video, we get to dive much more into M code. Don't forget that every time we use Power Queries, we're creating a query, which is a question we ask of the data. And those queries are built with M code. And every M code query returns values such as numbers, text, lists, records, tables, and functions. These values are what queries deliver. So we'll have to learn a lot more about these different values in Power Query. These queries are also created with a let expression, which we'll get to see. That is where all the M code magic happens. That means that M code is behind every query. Now, we want to start off by looking at 3 important places where we can go look at the M code or edit the M code. This is the same table we used last video. This is one of the reports we created. And over here, there's the query pane, and that's the Power Query solution we created from that table. We loaded it to the Excel sheet already. Of course, data, we opened up queries and connections so we can see this. Now let's double click this to open it. It opens up the Power Query editor. That's our query result. Over here, that's the name of the query. And here's our applied steps. Now, 1, 2, 3. Those are the 3 different places that we can look at M code or edit M code. Applied steps, formula bar, and advanced editor. Now, most of the time, people don't think of the applied steps list as a place where we can influence or edit the code. In the applied steps list, we can rename steps. We can actually go backwards and look at and then influence the code up in the formula bar. And we can use, if there's a gear icon, click that, and it opens up the dialog box we used to create that step. Now I'm going to click X, and the relationship between applied steps, formula bar, and advanced editor is this. This is the name. Up in advanced editor, we'll see that name. It's the name of the step. Then there's an equal sign, the Power Query function or other M code, all listed on a single line up in advanced editor. Now let's go look at the advanced editor. This is the advanced editor. That's the name of the query. These are our steps. Now we'll come back and look at the let expression in just a moment. But notice, there's the name of the step, the equal sign, and whatever our M code is. Now let's click Cancel. We want to talk about how to change the M code using applied steps. Well, the first way is we can come and rename our steps. So I have grouped rows selected, and now I hit F2. And we're going to name this Type Day Grouping and Enter. If I go up to Advanced Editor, we have a new name. Let's click Cancel. Now we can click the gear icon, and this is another way we can change our M code. But what I want to do is the same thing we did last video. Notice there is no text box for the fourth argument, which is the group kind. I'm going to click Cancel. Now, just as we saw last video, if we do a standard default group by, we get a unique list from the type day column, and then we get some aggregate calculation for each one of the items in this column. But that's not what we want. If we go look at our original table, what I really want is I want the total for consecutive occurrences. So I want the total for weekday, then the total for weekend, holiday, workday, donation, and so on. So with type day selected, we can come up to the formula bar. This is our second way of editing the M code. And we actually saw this last video. I come up, and the fourth argument, I type a comma, group kind dot, and it's local. That means no longer will it extract a unique list and do an aggregation. It now, with local, will get consecutive occurrences and then do the aggregation. Now, just as we talked about last video, that gear icon will go away when I hit Enter because this fourth argument is not in that dialog box. So when I hit Enter, there's our report exactly as we want it. But over here, the gear icon went away. If we go up and look at the advanced editor, sure enough, we use the formula bar to change our M code. I'm going to click Done. Now, another way we can use applied steps to change our M code is, if we think about this, these are consecutive occurrences. If we look at our original table, that actually depends on a sort on this column. If we actually changed the sort over here in this table, our report would not be correct. So no problem. Over here in Power Query, we can add a step and make sure that the date column is sorted. Now, we're using applied steps. We're going back a step. This can be dangerous because it's going to insert a step. So whatever the step is, it can't adversely affect any of the other steps. And for us, it'll actually help. So change type is selected. Now I come over to date and use the filter drop-down. Sort A to Z. Now it's polite. It asks us if we want to insert a step. I do. Insert a step. And there it is. We can look up to the formula bar, and sure enough, Table.sort sorted the date column. So now no matter how we sort it in the external data source, we have a step here that will assure when we go to the next step and do our grouping, it will group them together in the correct consecutive order. Also, if we insert a step and it adversely affects our query, then when we select the next step, we'd see an error or the incorrect result. But in our case, it's perfect. Now let's go look at the code, Advanced Editor. Notice sorted rows was inserted. Now we want to learn about the let statement. This is the heart of any query. As soon as we open up a query and start clicking around in the user interface, the steps will be recorded in a let expression or a let statement. Now, before we can talk about let, we actually have to back up and define what an expression is. Now, an expression is simple. An expression is defined as any M code that delivers a value. Values such as numbers, text, lists, records, tables, and even functions. And this let expression itself is delivering a value. That last step there, if I click cancel or done here, that's the value it's delivering. So if I go back up here, the let expression itself is an expression. Now, the thing about the let expression is each one of these lines is an expression in itself. Now, remember, an expression results in a value. I'm going to click cancel. Each one of these steps is an expression that results in a value. This step brought in the table. The value is a table. This one changed the types, but it's still delivering a table. So each step in our let expression is an expression itself delivering a value. The final value, the last step, that's what the query delivers. Now, just to show you a couple different expressions, if I come up to the formula bar, I can actually use the formula bar to create a new step. I click on that f of x, which says add step. Now, a simple expression in Power Query could be something like equals 43 plus 43. When I hit enter, well, OK, that's M code, and it delivered a value. Remember, numbers can be values too. Let's do another expression. I'm going to click the f of x, and I'm going to type equals. And guess what? I can pick any one of the previous steps. Now, for our example, it's not useful. But in some queries, you actually have to go backwards and get a previous step to do some new calculation on. But I'm simply going to type source. That's the name of our step. When I hit enter, sure enough, it resulted in a table. If we go to our advanced editor, every one of these lines itself is an expression that's delivering a value, and the let in total is also an expression. Now I'm going to click cancel. We'll come back to this in just a second. We can also use applied steps to edit the M code by using the red X. I'm going to delete that, delete that. Now let's go back up to advanced editor. And here's how our let expression works. It starts with the word let. And then we can have as many expressions or steps or variables, sometimes people call these, or transformational steps until we get our final output. Each expression or each step in our let statement starts with the name of the step. This is known as an identifier. The name of the query is also an identifier. But notice when we're dealing with identifiers or names, if there's no spaces, you simply type it out. The first and fourth step don't have any spaces, so we simply type it out. If there are spaces like change type, guess what? You have to use a pound sign and then double quotes. The reason is simple. Text already took simply quote, quote, or double quotes. So when Power Query or M code sees double quotes, it's going to think of it as text. And we need to distinguish and say, no, no, this is the identifier or name of our step. So we have to use a pound sign at the beginning. So each line starts with the identifier or the name, followed by an equal sign, and then it has M code. In our case, each one of these steps has a function. Later, we'll see we'll actually type M code out that is not specifically a function. The other thing that's very important about let is each line or expression ends with a comma. That comma says, please deliver the value. Notice, comma, deliver the value. Wait a second, the last step doesn't have a comma. That's because it's followed by in, and then the name of the last step is repeated so that that's the delivered value from our let statement. Also to notice, here's source. The very first argument, or if we have straight M code, the very first part of our M code is going to be the name of the previous step. That's because the source expression delivered a table, and we need to further modify it. So you can see change type. Well, of course, that's the first argument in table.sort. Sort rows, there it is. Now, you don't have to use the previous step. You can use any one of the previous steps. You can even use any query name in your workbook. But most of the time, we're stringing them together. Name of the previous step, name of the previous step, and so on. Not only that, but it's pretty polite. I'm going to cancel. I'm going to delete this sorted rows, delete. Come back up and look at the advanced editor. Notice that the names adjusted, source and change type. This type data grouping was working on the sorted step, but now when we deleted it, it totally updated. Now I'm going to click cancel, come over to change type. Sort, we are inserting. Insert. Up to the advanced editor, it's now looking at sorted rows instead of change type. Another thing about this let is you can actually, not that we want to do this very often, you can actually type any previous step or any other query name from the workbook. And when I click done, sure enough, that's the output. Notice our applied steps changed to a single line. I'm going to come back up to advanced editor, double click Control C, double click Control V, and done. And so we're totally allowed to work back and forth between applied steps, the formula bar, and our advanced editor. Now I'm going to close and load this, and I want to do a test. I want to see if this report will withstand us sorting. So I'm going to sort not on the date column, which gives us the correct order for type day, but I'm going to sort on the sales, largest to smallest. Now I'm going to come over and right-click refresh. And sure enough, it totally works. Now let's go over. I'm going to double-click to open up the query. If we look at our first step source, there it is. It came in with that new external sort. But when I come down to sort rows, that's our step. That is our safeguard for our final report. Now, a couple more things about M code. Let's come up to Advanced Editor. I want to show you how to add a comment, because what we did was to add group kind local. Now I'm going to come to the end of the last line, hit Enter, //. Those are the two characters together that says everything on this line is a comment, not executable code. And there we have our note. If I click Done, no problem, it still works. Now I'm going to click Close and Load. Now I went ahead and opened up a different workbook. Here's an example of, yes, the comment, // just one line. If you want multiple lines, then you put /, asterisk, and then you can have your lines, and then asterisk /. All right, now we want to go back to our query we just created. I'm going to double click to open this up. Go up to the Advanced Editor. A couple more important things. There are certain words like let and in, true and false in lowercase. Those are called keywords that are reserved. And of course, you couldn't call a step let. Also, when we see a function like table.transform column types, that's from the standard library. I'm going to click Cancel. There are some other things from the standard library. If I click f of x to insert a new step, notice that, of course, it's assuming I want to do something to the previous step, and so it has it highlighted. But what we want is equals number.e. Now, this doesn't have any parentheses because when I hit Enter, it just gives me the number e. That's actually a special number that pops up in lots of different places, especially finance. And of course, there's pi, too, the relationship between the circumference and diameter of a circle. Now I'm going to X out that step. Those are from the standard library. Now here's another cool trick. I'm going to click f of x, and let's say I do not know how to use number.round. That is a function that usually has parentheses with arguments. But if you just put it up here actually with an equal sign and hit enter, wow, that's cool. It gives me help right here in the Power Query editor. And if you scroll down, there's some cool information. Now, I usually oscillate back and forth between looking internally in the Power Query editor and the Microsoft site. Sometimes there's information in one that's not in the other. Another cool trick is if you come up to the formula bar and type pound, shared in lowercase, enter, it gives you a list of all sorts of things. Now, this is a record. If we convert this to a table, you then have a column. You can filter for exactly what you're looking for. So I'm going to type number and enter. And then I get number E, number pi. And if we scroll down, number round, and all sorts of Power Query functions. Now, let's get rid of this. Custom type, right click, delete until end. Delete. Now I'm going to click Close and Load. Now, before we go any further with M code, we have to talk about the different values in Power Query. Now we're going to keep picking on this query. I'm going to double click and open up that query. The very first type of values is called a primitive value. And if I come up to the formula bar and click f of x, I can simply type a number, for example, and enter. If I load this query, it will load a number. That is a single item, just like if I enter text and enter. That is a single primitive value. We have numbers, text. We also have Boolean values, trues and false. Now, if I enter true as lowercase, it shows up here as uppercase. But if I go over to the advanced editor, that's what it's like in M code. I can also double click this and type the fourth primitive value, null. That means no data. If I click done, that's a null value. So now I'm going to X this out. Now, this is a list of all the possible values in Power Query and M code. This comes from page 31 in our Formula Language Specifications Manual. From null all the way down to text, these are all the primitive values. Now, we didn't look at time, date, date time zone, or duration, but those are all date time related values. And if we ever needed to hard code a time, a date time, these are called the intrinsic functions that we can use. So if we literally wanted to hard code February 26, 2013, that's how we would do it. We wouldn't type 2/26/2013. We'd use that function. The next type of value is a list. Now, let's do a list this way. I'm going to click f of x, equal sign, and lists are very similar to arrays over in Excel. If I use curly brackets and then put any value separated by commas, that will be a list. Now, this only has one type of value, a number, but if I hit enter, oh, look at that, it's even polite. It shows list at the top to tell us that's a list. Now, lists can have any kind of value in any one of the comma-separated positions. I can have text. I could have another list within a list, comma. I could even have tables or records. We'll put a null, enter. Now, not very often are we entering lists like this. I'm going to X this out. Sometimes, if we want to extract a column, I could come up to the count sales and right-click the column. And if I drill down, it gives me the rawest form of that particular item. So if I drill down, that will give me a list. Now, lists will become important because some functions, like all of the aggregate functions, list.sum, list.standard deviation, those all expect a list of values. I'm going to X this out. Another interesting way to generate a list, if I click f of x, equal, and I need a huge list, and I don't want to type it out. We have always wanted this in Excel, ... 43, close curly bracket. That will give me a list from 1 to 43. Now I'm going to X this out. And be sure and go and look at the PDF notes. The PDF notes have a bunch of other examples also. Now, let's go look up at type day group step. Click the formula bar. Another awesome use for lists. Remember, the third argument of table.group is a list within a list that lists all of the aggregations. That means in the third argument of table.group, I can list as many aggregations as I want, and all of these columns will pop up. Now, this is a list within a list because table.group is programmed to have the column name, then the actual calculation, and then the data type. And then we go on to the next list within a list, and then it shows the column name, aggregation, and data type. Now look at the second argument. That is the column we want to group by. Why is it as a list? Because that tells you that that argument could accept more than one item. For example, when we group, we can group by more than one column. So really, right here, it's a single item, but we could put a comma and type another column name, and it would group by those two columns. So lists are very important. We also have records. If I come up to Add Column, Add Custom Column, we're going to add an extra column that will do some calculation for each row in this data set. I'm going to call this record. And we need a formula that will extract the record from each row. Well, there's actually a shorthand we use, underscore. Underscore will go in each row and extract everything as a record from each row. Now, technically, the underscore is part of a custom function, and we'll talk about that later. But when I click OK, there it is, a column filled with records. I can click off to the side, and sure enough, there's a record. Now, sometimes we're dealing with individual records, but even if you don't deal with a lot of records, you have to know it's a particular value that Power Query can generate. Later, when we learn in this video how to look things up, you got to first look up the record before you can look up the item. For example, if you wanted to get that number right there, we would have a table, then look up the record, and from that record, we look up a particular item in that record. The other reason that the record is important is notice when we did pound share, it showed up as a record. And then we converted it to something more useful like a table. Now I'm going to get rid of this step, come up to f of x, and just like we did with a list, you can hard code a record in. Now another term instead of hard coded is a literal. That means to hard code it in. Now records come in square brackets. We'll also see that other things come in square brackets like lookup operators and field access operators. But we type open square bracket, and then we have matched field names and values. I'm going to type sales, and this is one of the few places that you can have a word like this without double quotes. It is because we're using a field name in square brackets that we don't have to put it in double quotes. And then I'm going to say for that field, please let that be equal to 43, comma. The next field name is product. Now remember, that's a special case because it is the field name without any double quotes. They actually call that a generalized identifier, but it only happens inside of these square brackets. And the product, and guess what? This is not a field name. This is a value, so I have to put double quotes. Now, we hardly ever have to do that, but I just want to illustrate that we can hard code or create a literal record. And there it is. That's how a record shows up. You can see the record ribbon tab shows up when we show it as a record. That's the same ribbon tab that came up when we did pound share. Now, I'm going to X this out. Primitive value, lists and records. And of course, we have tables. If I come up to the formula bar equals, and I'm going to type source and enter. There's our original sort from the external database. That's a table value. The last type of value is a function, and we'll talk about that a little bit later in this video. Now, there is a way to get a literal table, and you can look in the notes. There's some particular syntax for that. But there we have our primitive list record table values. And we also have a function value, which we'll talk about later in this video. I'm going to X that custom out and click X on this. Now here's another look at page 31 in our formula language specification notes. These are all the values. The only ones we didn't look at are binary and type. Now type is actually the category for all the other types of Power Query values. And binary simply means we have some files like Excel files or text files. For example, we have earlier in the class had a content column filled with binary values, and they were our Excel files. Now, our next topic is lookup. Now, if you go look at the formula language specifications document, it doesn't refer to looking an item up in a table as lookup. It refers to it as projection and selection. Now, those are terms from relational algebra or database theory. Projection means to select a column. Selection means to select a row or a value. Now, we want to go look at the sheet lookup. And we'll go and open up this query, learn lookup in just a second. But guess what? If you're from Excel or other computer languages, if you know how to look up an intersecting value, meaning we have the lookup criteria, that transaction number and that column, there it is, intersecting value. If you know how to do that, or you know how to look up an entire column, or you know how to look up an entire row, then when we get over to how it's done in Power Query, it'll make more sense. Because guess what? If this is your table you're looking something up in, that's an intersecting row and column. So if from this table we know the row index number and the column index number, we'll have no problem getting the intersecting value. Similarly, that's the first column if we want to look up the column. That's the third row if we're looking up the row. Now, notice I said first column, third row. That's true here in Excel. But over in Power Query, it's base 0. This is column 0, column 1, column 2. Row 0, row 1, row 2. Now, for us Excel people, we probably know how to use the index function. Now, first, before using index, you have to use match. And what does match do? It looks up that item in a particular range and returns the relative position. Now, this is base 1. But if you know match and understand relative position or row index number, then you'll understand more easily how it's done over in Power Query. Similarly, we looked up that color within that range to get first column. Then, of course, we used the index function. And look at the arguments. In index, we definitely require a table, an index number, and a column number. Now, when we get over to Power Query, it'll be in the same order. When we do our lookup formula, we'll first have to list the table, then the row index number, then the column index number. Also, here in Excel, of course, we can look up an entire column of values using row number 0, which means please give me all the rows. And then, of course, index looks at 1 and gets that column. Similarly, we could look up a row by giving column index number a 0, which means give me all the columns. All right, so in Excel, we can definitely look up an intersecting value, a column, or a row. The most important thing is table first, then row number, then column number. Now, wait a second. I thought we already did lookup back in video 6 and 7 in this class. Remember, we needed to look up a product name from a different table and get a supplier code. Well, that would involve taking two tables and merging. No problem. That's one way to look things up. But when you're looking something up from one specific table, the way it's done internally inside of Power Query is going to require that we have a table, a row number, and a column number. Now let's go over and open up this query, learning lookup. All right, this query is named Learning Lookup. There's only one step, and there's our table. Table, row, column. But before we look at lookup, we have to talk about drill down. Now, we've already seen drill down. Let's just try it. I'm going to come to this cell right here, right-click, drill down. Now, there's the result. If we load this query, it's a primitive value, a number. But look at the formula. That's a lookup formula. Table, row index number, and the column index number. Now, the column index number and the row number seem totally different. That explicitly is saying, please give me the 5th row. That's not giving me a number, but it is telling me which column to select from. So the convention for looking something up, please give me the table name. Then in curly brackets, that's called a positional index operator. Please give me the row number base 0. And then in square brackets, please give me the column name. Now, as we'll see, there's actually 2 types of lookup. This is called row index lookup. Now, I want to go back to source. And we're going to go back a few videos. I think it was video number 5 where we talked about the Excel.currentWorkbook function. Notice that's the source step. When you click Import Table from Range, that's the code that's generated. But look at it more closely. Excel.currentWorkbook delivers a table. Oh, there's the curly brackets. That's telling me the row number. And then in square brackets, that's the column name. So in essence, it's looking up from a table using a row and column index number. Click Shift and arrow, Control X, and let's remind ourselves what Excel.currentWorkbook returns. When I hit Enter, I get a table that contains all of the objects from the current workbook. Now, the one we would like to try and get is in the 3rd row. That entire table is what we're after. So if our goal is to look up that table, well, there's a table. I come after the table, and we're going to hard code it in using our positional index operator, curly brackets, 0, 1, 2. So I'm going to put a 2, close curly bracket. Now I have the row, but I also need the columns, square brackets, and the name of this column, content, close square bracket. That's our 2-way lookup. When I hit Enter, I have looked up that table. Now, that code is not quite what the From Table Range button generated. So we're going to try this again. Delete and Enter. Instead of hard coding curly bracket 2, we can actually look up the name of the object that we want to look up and extract. So I'm going to backspace. And now we're going to, inside the curly brackets, which is the positional index operator, we're going to use square brackets as lookup operator. Now, when we have square brackets, we can put the field name without any double quotes. So I say, hey, name, is anything in that column equal to F transactions, end double quote, close square bracket, close curly bracket. The curly brackets are the positional index operator to get the position of the row. The square brackets are the lookup operator. That will tell that table to go and get the 3rd row. But we don't want the 3rd row. We want the item from the content column. So we do square brackets to look up the column name, content, close square bracket. And when I hit Enter, Power Query is so polite. And of course, it's case sensitive. And I had the wrong case. Let's try little f, big T. And when I hit Enter, there we have table, row index number, column index number to do a 2-way lookup to look up our table. Now, that's the code that's automatically generated when we click From Table Range. Now, I want to go back over to navigation because here, table, row index number, and our column indicator. That 4 is hard-coded in. This method of lookup is called row index lookup. When we see curly brackets and then square brackets to look up something, this is called key match lookup. Now, it's called key because it is assuming that the column it's using to look something up has a unique list of values or is a primary key and that there are no duplicates. Now we'll come back and actually investigate that name column in Excel.current workbook to help us understand what key match lookup does. But let's go back to navigation. I'm clicking on that step. Row index. That's when we have hard-coded row number. Key match. That's when we have some column that's a key column, and we're trying to find a match. The difference between the two is important. That 4 is hard-coded in. No matter how I sort this table or change it, it's always going to get the 5th item from the red column. Whereas when we're doing key match, we could sort that table or change the table, and this type of lookup will always find F transactions. Now let's take a closer look at both methods. I'm going to go over to navigation. All right, so that's getting the 5th row item. Let's go to source. Let's sort the table and see what happens to row index. I'm going to sort red ascending. I'm going to insert a step. 1, 2, 3, 4, 5. Uh-oh, there's the 5th item. So now when I go over to this step, sure enough, and notice it's polite. It totally updated knowing that the previous step name actually changed. But there it is. It's hard-coded in. It's getting the 5th row no matter what. I'm going to delete that step. Back to source. All right, I'm going to remove the last part of this. Control X and Enter. Now we have a table. I'm going to sort this. I'm, in essence, adding a step here. And there we have sorted. F transactions is in the last position. I'm going to insert a step by using F of X. Insert. That's a table. And to do two-way lookup, what do we need? Row and column index number. Now when I hit Enter, no problem. That method will always find F transactions. Now I'm going to delete both of these steps. Come back to source. Come up to the formula bar, Control V, and Enter. Now we know the two different lookup methods. And we want to talk about what happens when we do drill down. I'm on the source step. This looks like a unique list to me. I want to right-click and drill down. Actually, this navigation will replace that one. That's OK. Continue. Look at that. I thought we said if we had a unique list, it would do key match lookup, but it doesn't. It did row index lookup. The reason it did when we did drill down is because this table doesn't have a primary key. What? There's primary keys in Power Query? You can click through all the ribbon tabs, and I can't find anywhere that helps us find out whether a table has a primary key. Well, we're going to have to talk about primary keys in Power Query. And yes, there isn't a button. At least I couldn't find one anywhere. Let's go back to this original table. Enter. The way that we can find out if a table has a primary key is we're going to insert a step. And we're going to use the Table.Keys function. Table.Keys asks the question, hey, does that table have a primary key? A record is returned, and sure enough, it says true. It does. I'm going to delete that step. Back to source. Come up here, Control V, and Enter. So when you're drilling down on any particular column, if there's no primary key on the table, it will do row index lookup. If this table were to have a primary key, then it would do a lookup on the primary key column, just like Excel.current workbook did automatic when we click the From Table button. Now let's prove that to ourselves. We're going to insert a step. And we're actually going to add a key. Table.AddKey without an S, open parentheses. There's 3 arguments, comma. We have to tell that table which one of the columns we want as a key. It is a list because you can have multiple columns to define a key. I'm going to say in double quotes, end list syntax, comma, and then lowercase true, close parentheses, meaning that is going to be our primary key. It didn't change the table at all. But watch what happens when I right-click, drill down. Continue. Now it does key match lookup. There's the name of the table, positional index operator syntax, square brackets. That's the name of the primary key. Are you equal to that value? That gives us the row number, and then there's the column indicator. I'm going to come back to custom. That means I'm going to get rid of the step where we added a key. So I'm going to get rid of it. Use the red X. And now let's go to source and watch this. If I right-click and then click on Remove Duplicates, if I use this feature, I'm going to click Insert. There's Table.Distinct, Source, and there's the column. Guess what? Behind the scenes, this table now has a primary key. Now, of course, we could do the Table.Keys. Does the table have a key? And it will return a record, and the record will say true. I'm going to get rid of this. That remove duplicate step, now if I right-click, drill down, continue, sure enough, it took the table and it did key match lookup. I'm going to go back to remove duplicates. X that out. Back to source. So in Power Query, we will get a primary key on a table when we use Excel.CurrentWorkbook, because that table generates a table that has a primary key. When we use remove duplicates, when we use the actual function Table.AddKey, or when you connect to a database like an SQL database where there are primary keys. Now, a couple more things about key match lookup. We actually can manually generate some code. I'm going to insert a step, click Insert, and we're going to work off of the product name. Notice this isn't a primary key. This is not a unique list. But we're going to try it anyway. So we have positional index operator, lookup operator, the name of the column. I'm going to say, are any of you equal to quad? Close square bracket, close positional index. And I want to try and get something from the date column. Right? Notice there are lots of duplicates. So when I hit Enter, the error we will get is the key matched more than one row in the table. If, on the other hand, we ask for something that is completely not there and hit Enter, the error message says the key didn't match any rows in the table. Now, there is one record at the bottom, and we sold the product Aspen, and there is only one Aspen in that column. So it will work. So when manually creating key match lookup, you're either going to get a duplicate error, not in list, or if it, in fact, is the only item, it will find it. Now, I'm going to backspace through this and Enter. The one last topic about lookup is, remember, we've been looking up individual items, right? Well, we can look up a full column or a full row. Now, I actually already did the full row. For example, if I say, give me the fourth record, that right there, without the column part, will return a record. That's looking up the full row. Now, we can also look up an entire column. We just skip over that second part. We don't put in a row index. For example, I could say, please give me the date column. And when I hit Enter, it will return as a list. If you want it as a field and data, a one-column table, then you have to put double square brackets and Enter. Not only that, but that's the convention for selecting multiple columns. In square brackets, you list the field names in square brackets, comma, and we could say product name, close square bracket. And this will select two columns. We could also, as we did over in Excel with index, we limited our table to just these three columns. But if I wanted just the three numbers from these three columns, well, I could say, please give me the first row. And then this is called projection when you select certain columns. Red, blue, silver, close square bracket, and enter. So we could get just those 3 items from that particular row. All right, delete and enter. That was a lot about lookup. We saw how to do row index lookup where we hard code the row number in, and we learned a lot about key match lookup. All right, now I'm going to close and load this, and it will load back as a connection. Now our next topic, if we go over to the sheet custom functions, yes indeed, we're going to learn how to create custom functions in Power Query. Now I've already imported this table. I'm going to come over to loan rate table. That's a query, and double click and open it up. Now my goal is to take annual rate and number of periods per year and calculate the effective annual rate. Now I could just come up to add custom column and do the math right in a column, copy it down, done. But if I want a function that I can use over and over, that's where custom functions come in. Now what I mean by over and over is once we create our function up in Advanced Editor, we get to use it in this Excel file over and over. If we open up a different Excel file and want to use it, then we'd have to copy our Advanced Editor code over to the new Excel workbook. If you know Excel user-defined functions, which we create with VBA, over in Excel, we can save it in a personal workbook so that anywhere on our particular computer, we can use that function. But I don't know how to do that over here in Power Query. But nevertheless, it will be very powerful to create a function that we can use over and over in a particular Excel file. Now, we're going to create a blank query. So I'm going to come over to Queries, right-click, New Query, down to Other Sources, and blank. Now, the function that we're going to use over and over is going to be called effective annual rate. The name of the query will be the name of the function that we get to use over and over. So effective annual rate, and enter. Now we have a blank query. I'm going to go up to Home, Advanced Editor. There's our function name. We're going to use the let statement to define our effective annual rate function. Now, the name that we give this step, if we repeat it as the output for this query, then the query will deliver a function. Remember, one of the values in Power Query is a function value. Now I'm going to highlight just source, and the step name will be. And if I want the query to deliver the function, I take the step name and paste it after the in. Now, we as the designers have to create the arguments, then use the go-to symbol, and then describe how the arguments should be used to calculate the final result. Arguments go in parentheses, just like they do in Power Query functions, DAX, and Excel functions. The first argument will be annual rate, comma. The second argument will be number of periods. Those are the only 2 inputs or variables or arguments or parameters for our function. Now we put the goes to symbol, equal sign, greater than. Then everything that comes after is how we use these 2 arguments to make our calculation. In parentheses, 1 plus annual rate divided by number of periods. Close parentheses. And I would like to use caret because we have to raise 1 plus, better be plus, or 1 plus that conversion to a period rate. We have to raise that to a power. But that's not one of the operators available to us in Power Query. So no problem. I'm going to use the number.power function. Now I'm using a built-in function inside my custom function. And I don't need that parentheses. Then I take whatever is the first part, that's the base, comma. And we need to raise it to, I'm going to double-click Control-C and paste it there. Then we subtract 1. And that's it. When you create a function, parentheses, arguments separated by a comma, go-to symbol, and then however those arguments are used to calculate the final result. Now for us, this is a simple math calculation. But guess what? You can use parentheses in the goto symbol and have many complicated steps. For example, our next example will have lots of steps to transform a data set. In either case, we're creating a function that we can use over and over. When I click OK, look at that, f of x. That's a value in Power Query. It's also a data type. So if you have a column filled with functions, the data type will be function. Look at that. It even gives us a little description there. Now, I actually want to go change it because as we did it, it comes up as any, which is perfectly all right. And I'm going to go back up to Advanced Editor. We're totally allowed to define the data type. And we're going to do that by saying as a number. Same with this one, as a number. So we have given a data type to our arguments. We can also, before the goes to symbol, give a data type to the actual function as number. Now you can also add optional arguments. And there's some notes in the PDF notes, but we're not going to do that here. Now when I click OK, look at that. Now down here it says function annual rate as a number of periods as a number, and then the function as a number. Now we can use this name in other queries, or for us, we're going to create a calculated column. So I'm going to go back to loan rate table. Now we're going to add an extra column, so we go to add column. Invoke custom function. I'm going to click that. It wants to know the name of the column, effective rate. And there we have, from a dropdown, our effective annual rate function. The annual rate, this is asking for that function as it copies down the column. Do you want to either put in a number or a column name? We definitely want a column name. So we'll select annual rate, column name, number of periods per year. Now when I click OK, that is awesome. Well, wait a second. I forgot. I wanted to define my custom function to round. So no problem. I can come back over to effective annual rate. I'm going to right-click, Advanced Editor. And right over here, we're going to number.round, open parentheses. And then after the -1, 4, close parentheses, click Done. So the function has updated. And when I go over to loan rate table, that is beautiful. Now I'm going to go to Home, Close and Load, and this will close and load to a connection. Now we want to look at a different type of function. I'm going to double-click from folder, many bad tables. I'm going to double-click. Now this query here takes many files from a folder and gets to the Excel sheet. But the problem is this is a cross-tabulated table. And how could I unpivot and transform and do all the necessary steps to every single table? Well, I can first import one table, transform that one table into a proper data set, convert it to a function, and use that function in a custom column. So let's go over to Queries. Let's select Bonnie. We imported one table and did all of our transformation steps, transpose, promoted headers, unpivot, and rename columns. Now I want to convert this to a function. I'm first going to rename it, function to transform fair tables. Now go up to Advanced Editor. I do not need the first two steps. I'm going to delete that. I'm going to come right before let, enter, up arrow, and I'm actually going to define the function above the let. Input table, close parentheses. There's only one argument. And then I'm going to use the go to symbol. Now double-click Control-C, and the very first argument for table.transpose, Control-V. Now this function has a special name. It's a parameter query. We're in essence defining just a single input variable that we want to use as the first step. And then the remaining steps will then transform the table and deliver it as the final step, a proper data set. Now we want to notice two things. The function doesn't have a name because it's not a step inside the let function. And this query doesn't deliver a function like the last one. It's just using a function to get an input variable. The output of this query is the final step a proper data set. Now when I click OK, that now is a function. I can come back to from folder many bad tables, add column, invoke custom function. We'll call this convert to proper data set. And now we have two functions. I'm going to select function to transform table. And that data column is already there. I'm going to click OK. There is a bad data table. There is a proper data set. So we used a parameter function to convert each one of those tables to a proper data set. Now we could take this column and then combine them into a single table. But in this section of the video, we're just talking about custom functions. Now, I want to do one more example with query inputs. I want to go to the first step of this query from folder many bad tables, the source. And notice there's the line of code, and it's got a folder address there. And I'd like to have the folder input come from Excel. So I can type any folder path and have it reflected in this line of source code. So let's close and load. I already created an Excel table. There's the current folder path. I imported this as a table, and there it is. Now to use it in another query, right now this is a table value. I want to right click and drill down. I'm drilling down on the value. And so now I get some text that represents that folder path. Now I'm going to close and load this. This is loaded as connection only. Now I can come over to from folder many bad tables. And in the first step, I'm going to backspace. And if I look over here, that is the query name. F2 to copy it, Control-C escape. Now I'm going to come back over here, source, and right in this argument, I'm going to Control-V. You bet I can totally refer to any one of these other queries. When I click Enter, it's picking up from Excel the folder path. If we go look at Advanced Editor, all we did is use a query name. We didn't have to define a function or anything. Click Done. Click Close and Load. And so now, wherever that folder is that you have 09 parameter query tables, if you downloaded it from below the video, you could put that folder path there and boom, refresh everything, and it will work. Now we have one last topic related to custom functions. I want to go over to the sheet Sales, and I want to double click and open Sales Needs Rounding. Now we want to add an extra column and create a formula. And then look at each and underscore so we can understand how those are working like custom functions. Now I'm going to go to custom column. We'll call this rounded sales. And we're going to do a simple formula, number dot round, open parentheses, and I'm going to double click sales, comma 2, close parentheses. Now a custom column will copy this down and calculate for each row. When I click OK, there's the result. I can look at the formula bar, Table.add column. That's the previous step, the name of the column, and there's the calculation. And that each right there, it's actually shorthand for an unnamed custom function. Now to illustrate that using each as a shorthand for a custom function is much easier than doing the custom function, I'm going to go up to Advanced Editor. There's the step right there. There's each. I'm going to come to the end. This is no longer going to be the last step, so I type comma, Enter. I'm going to Control-V. And here's what I did. Instead of simply using each and then putting the column name, here's what each is shorthand for. Oh, there's the parentheses. Inside the parentheses, that's the name of the argument. Underscore is a single character name for the argument. Then there's goes to, and then we list underscore as the argument, which says for this row, as the formula is copied down, use the item from the sales column. So when we see each, and most of the time it's just put in for us by custom column functions, each, that's much easier than typing all of this and then our underscore in front of the column, so we get just the column for that particular row. Now, that underscore You can actually think of it as getting the entire record. Remember when we talked about lookup, we need the record before we can specify the column. So whenever you see each, if you use just the underscore, you'll actually get the whole record for the row. Now, we already saw that example earlier in this video. Now, before I load this, notice we have custom, custom, added custom twice. So I'm going to change the name of this to 2. Right? Now it'll load this last step as the final result. When I click Done, notice here we used each and then the column name. But notice it's actually acting on change type. So is this step. But of course, we explicitly put the custom function that each is shorthand for. Now I want to do one last example here. Go to Add Column, Custom Column. Anytime we do custom column, it'll add the Table.AddColumn function. And of course, it will use each. So if I want the whole record, I simply put underscore. In conjunction with each, it'll simply get the entire row. Click OK. And there's the record. We can see each and underscore up in the formula bar. All right, now I'm going to go to Home, Close and Load, and this will close back to the connection. Wow, that was a lot of fun with Power Query and M code. And don't forget, we can edit or influence the M code using Applied Steps Formula Bar or Advanced Editor. We talked about what expressions were, the amazing let expression. We talked about values, primitive list, record, table function, and more. We talked all about lookup, custom functions, parameter functions and queries, and even each and underscore. Now, there are some more topics in M code, but if you want the basics so you can do amazing data transformations, there you go. All right, if you like that video, be sure to click that thumbs up, leave a comment, and subscribe, because there's lots more videos to come from Excelisfun, including next video, video number 10. We're going to take what we learned with M code and do an amazing transformation in Power Query, but over in Power BI Desktop. All right, we'll see you next video.